Hello, and welcome to Probability Distributions and Random Variables. My name's Tuesday Johnson. Here's an introduction to concept with applications. Alright, so let's talk about notation and definition first. When x, capital X, remember capital X is a random variable, the collection of probabilities of x equaling each of its possible values is called the probability distribution of capital X. And we use probability distributions a lot in games. It's how people create games. The probability that a random variable capital X is equal to any one of its outcomes little x is written P of x equals x, and this gets super confusing, so make sure you're using the capital X for the random variable and the lowercase x is for the actual value that comes out. Let's take a look at an example. There are 20 people in your class and their current grade point average has been recorded. And here's a table that has all the GPAs, and 4s, 3s, 2s, and 1s. What we want to do is we want to sort the data into measurement classes. All right? Measurement classes are ranges of values that we might consider salaries from, say, 20,000 to 39,999, 40,000 to 59,999, or GPAs in this case 1.1 to 2.0, 2.1 to 3.0. You know, we're always breaking things up into various ranges of values based on what it is we want to measure. And in this one, we're just going to use 1.1 to 2.0 because I said so, because that's the example. So we'll look at the class, right? We call this a measurement class. So I'm just going to call it a class here, 1.1 to 2.0, and I look. How many of these grade point averages are between 1.1 and 2.0, including, so that's 1, 2, 3, 4. 4 of those values. So 4 times in this list will the value of capital X be a value between 1.1 and 2.0. How many values between 2.1 and 3.0 do we have? Well, we look here, 1, 2, 3, 4, 5, 6, 7. 7 values. And the other 9, the rest of them, are going to be 3.1 to 4.0. That's it, right? So if we have all of our data, we could sort them into classes. We could group them up however we choose to group them, and we could count how many outcomes the value of capital X are in each measurement class. Now, using this measurement class, instead of writing down the class, you know, mathematicians are a little lazy sometimes, all the time. Statisticians not so much, but mathematicians for sure. We don't want to keep writing 1.1 to 2.0. What we do is we use a representative from that measurement class, and we generally use the midpoint, but it's like the rounded midpoint. If we find the midpoint of 1.1 and 2.0, it will add these up, right? We get 3.1 when we divide by 2. That'll be 1. What did we say? What did I say? I said 3.1. That'll be 1.55. All right, but we don't use 1.55 as the midpoint, the true midpoint. We use the rounded midpoint. What's the essence of this is between 1 and 2, between 2 and 3, between 3 and 4. So as we use a rounded midpoint, we're just going to call that, what's between 1 and 2? 1.5. What's between 2 and 3? 2.5. So we use a rounded midpoint in order to establish our x value, our lowercase x value, instead of using the class itself. So we might ask ourselves, what is the probability that capital X equals 1.5? And we're not actually saying how many people have we're not looking at the probability that your grade point average is exactly 1.5. It's a representative from the entire measurement class, all right, from the entire measurement class. And since there were 20 total values, frequency is 4, a probability of capital X being 1.5, or in the measurement class from 1.1 to 2.0, is 4 out of 20, 7 out of 20, 9 out of 20, and so on. All right, so from a table of values, right, we could group them into measurement classes. Using measurement classes, we could find the rounded midpoint and create a probability distribution. And with that probability distribution and our midpoint, our rounded midpoints, we can find a probability. For example, the probability that capital X is greater than or equal to 2.5. Well, the probability that the random variable is greater than or equal to 2.5 will be the sum of the probability x equal to 2.5 plus the probability that x is equal to 3.5. All right. So what are those probabilities? That's 7 out of 20 plus 9 out of 20. So in this particular class, the probability that you randomly pick a student and their GPA is greater than or equal to 2.5 is 80%. 80%, pretty smart class. Does that mean it has to be above 2.5? Nah, it could be 2.1 and it's still in this class. All right, so keep in mind, this is our rounded average. This is our representative. But think about what that actually measures. It's that whole measurement class. All right. I thank you so much for watching. Don't forget to subscribe to Math with Tuesday on YouTube for more of your math video needs. Thanks for watching.